Okay, let's begin. Welcome to my talk. I'm glad to see that the room got so full. I wasn't sure what to expect exactly. It's my pleasure today to introduce a new Eclipse project, the Eclipse Layout Kernel. I'm Chris, that guy over there. Tristan was originally scheduled to do the talk with me but couldn't make it to the conference, so you're pretty much stuck with me today. Okay, the Eclipse Layout Kernel formerly used to be the KLayout project. So it has quite a long history. We actually started the project in, I think it was 2008, even before I got to the group that started developing that. You can close the door. This is all about diagram layout. And when I say diagram layout, the question is, what do I mean by diagrams? I don't mean this kind of thing. So this is a diagram, but those are not the kind of diagrams we're talking about today, right? So the layout of these kinds of things are pretty much fixed. We're talking about diagrams that look much more like, for example, this thing. This is a typical class diagram. You've all seen these kinds of things. And it's very easy to understand what this is supposed to tell you. So we have a few classes that inherit or implement interfaces, interfaces that inherit from other interfaces. It's all very clear. This is a very valuable diagram because it immediately and very clearly tells you what's going on. Okay? This is very valuable, but not just because it's visual. Just being visual in nature does not make it valuable in itself. This is another version of the same diagram. This is also visual, but it's not very valuable. Well, except I think I could sell that as modern art. Then it would be valuable, but it's not really valuable in terms of giving you any worthwhile information. The thing is, elements in diagrams must be placed properly to give you value, to actually help you understand stuff. But placing elements in a diagram takes a lot of time. And there are people, as with everything, who estimated how much time it takes. So let's take a look at what they think it takes. And they estimate that developers spend about 70% of their time developing and 30% of their time moving things around. Now, we have to be careful with such numbers. So what do these numbers actually mean? The people who did this estimation actually sat down with developers who were using visual languages to develop, I think it was automotive software. And from watching these people, they estimated exactly these numbers. How exactly these numbers fare out depends on what kind of diagrams you're working with. If I'm just to draw a class diagram, then it might look like something like that. This is a wild guess done by me, so, okay. I might spend 40% of my time selecting stuff that I actually want to show you, and I'd spend 60% of my time moving the stuff around so that you actually get any value out of what I'm going to show you. Now, if we see these kinds of numbers, whatever exactly the numbers are, then it tells you that diagram layout takes a lot of effort. And us being computer scientists or developers or whatever, the first thing we immediately think about is, why not let the computer move things around instead? So we have this machine here, why not let it compute stuff? And well, there's a reason for that. If we take a hardness scale from easy to hard, and just for context, if whistling is over there, and people already have a very hard time whistling, some people, then automatic diagram layout is over there. It's a very, very hard problem. And there's several different reasons why it's a hard problem. I'm going to share two of them with you. The first thing is we want to have a good diagram layout. But the question is, what is a good diagram layout anyway? What is good? The first thing is we can define several metrics like the number of edge crossings or the length of edges or the size of the diagram. And they're all fine and good, but what kind of combination of these metrics actually result in a good diagram? I would much rather take, well, a few more edge crossings but have a smaller diagram in one kind of diagram. But in another kind of diagram, I might want to increase the straightness of edges so that I can draw as many edges as possibly horizontal without any kinds of bend points. And this might not work for another type of diagram. So what is a good layout anyway? It varies between diagram types, and it's not even clear for a single diagram type. So that's one thing that makes it hard. And the second thing that makes it hard is, for example, we have one very sophisticated layout algorithm that we split into 5 different phases. And pretty much every one of those phases contains NP hard problems. Well, that's not the kind of problem you just sit down in the evening with a bottle of wine and just hack it away and solve the problem. At least not most of us, but me anyway. I can't do that just in an evening, at least not after a bottle of wine. So that's where the Eclipse Layout Kernel comes in. We provide two things. We first provide a number of implementations, Java implementations of layout algorithms. And the second thing we provide is an infrastructure to connect to those algorithms with your editors that you want to provide automatic diagram layout for. Just as an aside, if you think that this logo is kind of lame, you're right. We're just a new project, and it's been very hard to draw an elk, so Eclipse Layout Kernel. So we're not that far yet. But if you're a good graphic designer, just talk to me afterwards. Okay. Good. How's this thing structured? The anatomy of an elk. Might look a little different than in biology class. We have basically three components to it. The first is the core component, which is the infrastructure that connects everything. If you have a diagram layout, a diagram editor, you would try to connect your editor to the infrastructure. If you're a layout algorithm developer, you'd connect your layout algorithm to the infrastructure. And the cool thing is, through a single data structure that we currently call the K-graph, that's about to change, we'll come back to that later, we have the ability that once you have invested the work of connecting your editor to the infrastructure, whenever we add a new layout algorithm, or even a newer layout algorithm library, you'll immediately get access to the algorithms. Okay, so that's the basic idea. During this talk, we'll concentrate on that part. So we'll concentrate on trying to connect your diagram editors to the Eclipse Layout Kernel. And that's actually what we're going to do just in a few moments, right? So I have a live demo of connecting diagram editors. We're not so much concentrating on this part, or on the layout algorithm part. So if you are a developer of layout algorithms, sorry, this talk is not so much for you, but just get back to me afterwards. I'll be here for the whole conference. Okay, so you have a rough idea of what the Eclipse Layout Kernel might be. Let's start using it. And I've broken down using the layout, the Eclipse Layout Kernel into three distinct steps. The first would be installing the whole thing, which is kind of obvious. The second part would be connecting your diagram editor to the layout kernel. And the third part would be one of the most important, which is configuring automatic layout so it suits your kinds of diagrams. Okay, to demonstrate that, I brought a very sophisticated example. Who of you has ever done one of the GMF tutorials? Okay, that's almost 20%. This is one of the tutorials. This is the mind map editor that you get after working through one of the tutorials. It's very basic because I haven't done much work to improve it. But this is what we're going to connect or to provide automatic layout for. Okay, so this will be our example. Okay, let's start by installing. What is there to install actually? As of now, we only have a nightly update site because we're a very new project, and actually the nightly update site is only there because I wanted to get something for you guys to play around with ready for the conference so you can move off and try things out. You'll find there's 4 features you can install. The first would be the core Eclipse Layout Kernel. That contains the core infrastructure and a number of layout algorithms that we provide for you. The second thing you can install is Graphis support. So Graphis is a, I think, EPL licensed open source library of graph layout algorithms that you can install on your computer. And installing our Graphis feature actually enables you to, or enables the Eclipse Layout Kernel to make use of that library. It gives you, like, I don't know, 6 to 8 more layout algorithms to just play around with. The next thing you can install is OGDF support. Now, OGDF is another one of those graph layout libraries, but it's not EPL licensed, so we cannot really put it into the Eclipse Layout Kernel. But at our old home, the Kiel University, we actually have a feature that implements OGDF support and gives you that. So, but it's not technically part of the layout kernel. The next thing you can install is support, out-of-the-box support for GMF-based editors and for Graffiti-based editors. The GMF-based support is that which we will be using just in a few moments. The Graffiti-based support we will not be using during this talk. GMF-based support works out of the box very often. So if you're lucky and you have a GMF-based editor, you just install GMF-based editor support and you're pretty much done. Okay. That's the installation step. I won't show you that in the demo because it's boring, but I've already done that. So let's get back to the next step. Once the Eclipse Layout Kernel is installed, we need to connect your diagram editor to the layout kernel to make use of automatic layout. So how is that done? You remember this diagram? We'll come back to that during the talk all the time. So after the talk, you will remember this diagram. And the interesting part is that the one of connecting your diagram editor to the layout kernel. And we'll concentrate on that and expand that a bit. And the way that you connect layout or your diagram editor to the Eclipse Layout Kernel is through so-called iDiagram layout managers. So basically what the Eclipse Layout Kernel does is you press a button and it finds out what the current editor or the current selected element is and checks if any diagram layout manager is registered for that kind of editor that can give it a representation, a K-graph representation. You remember K-graph, the central data structure, a K-graph representation of what's in the diagram editor. So once it has this representation, the layout algorithms can go do their stuff, compute layouts, and then we go back. How's that done? Basically, there's two methods, two important methods. There's a few more, but they're not as important. The first would be build layout graph. So the Eclipse Layout Kernel will ask the diagram layout manager to build a K-graph representation of whatever's in the diagram editor. Right? Okay, then the layout kernel goes off, triggers automatic layout, and we come back. We have layout information computed for us, which is the very magical, cool pixie dust part, and apply the layout information back. The layout kernel has no idea how to apply layout information back to your editor, but your diagram layout manager has. Right? So we provide a GMF-based diagram layout manager, and it knows about how to transfer the layout information back to your GMF-based editor. Now's the time for a bit more details on the K-graph. So what does actually come out of that method? So this is the central data structure. It needs to be mentioned in a talk about the Eclipse Layout Kernel. Basically, the very most basic element in a graph is a node. Even a graph itself is a node. How can that be? Because nodes contain other nodes. If you have a node, it can contain other nodes. The graph itself is just a big node that contains other nodes, right? So you already get hierarchy out of the box. It's not a flat graph, it can be very hierarchical. Nodes can contain other nodes. Now, nodes themselves wouldn't be that interesting. We need edges that connect nodes that have a source and a target. And now if you imagine a visual language that is there to represent formulas, mathematical formulas, then you might imagine that you have a division actor. And the division actor gets two numbers, divides them, and outputs the result. Now it suddenly becomes important whether your edges connect that way or that way, whether you divide that number by that one or the other way around. So what our graph structure supports is the notion of dedicated connection points, fixed connection points, and that's what we call ports. Each node can have arbitrarily many ports, and edges connect to ports on the source and on the target. Don't have to, but can. Now a diagram is very, well, imagine this diagram without those labels. That would be kind of, well, useless. So we also support labels that can be attached to pretty much anything, to nodes, to ports, to edges. And so far, that's only structural information. I have a node that's connected by an edge to another node, and it has a few ports and stuff. What we are lacking as of now are layout information, the actual positioning information. And that's what the K-shape layout is for. We can augment each of those things by a K-shape layout, which contains an actual size for the element, for the node, or for the port, and an actual position. And okay, an actual size and a position is not enough for edges to be represented properly, so we have a special K-edge layout for edges that contain band points and stuff, allows us to route edges around the diagram. Okay, for our very simple GMF-based editor, automatic layout, the GMF support already works fine. And what the GMF support already gives us is that layout button. Okay. Oh, I'm noticing that there's a few other buttons. That comes from the oomph tutorial today. I hope that didn't do anything bad to my demos, but I'd have to go and talk to Ike about that. Okay, once I hit the layout button, this is what happens. This is our standard automatic layout algorithm. It's called KLayout, or was called KLayout. Now it's Eclipse, which is a bit harder to pronounce, but anyway. It's a layer-based layout algorithm, and you immediately notice it looks sort of tidied up, but it's not quite the best thing for mind maps. So that's what we're going to work on next. We have to configure automatic layout to suit our kinds of diagrams. That's the next thing we need to do. We have connected our diagram editor to the Eclipse Layout Kernel. Now we need to configure layout. So how is that done? Let's come back to this diagram. We will now be concentrating on this part. I just told you that K-shape layout and K-edge layout contain positioning information. That was sort of true. Well, it was true, but it wasn't the complete truth. So let's get rid of the other stuff and see what else they contain. They both inherit from a class called KLayout Data. And KLayout Data is just a map or a collection of properties. And the properties are nothing more but triplets of an ID that identifies the property, of a value of that property, and a default value. If you just say, I don't care about that property, just take whatever you want and go do your thing. These properties are attached to pretty much everything in the K-graph. You can attach it to the graph itself to set a layout algorithm. You can attach it to an edge to, I don't know, specify certain routing information. You can attach it to a node to mark it as a comment in the diagram, which gets placed differently than a normal node, than a regular node. And this is our main configuration mechanism. The question though is, I got the K-graph, or the layout graph, out of my editor through the pre-installed GMF diagram layout manager that we provide. So how do you get the properties into the graph? And that's the last thing we're trying to solve. And there's many different ways of configuring that. And we're currently in the stages of overhauling all of that. But I'm going to share the simplest way to configure layout with you. It's a very static configuration, and it's Eclipse, so we're using an extension point, right? It's the layout configs extension point, which you can plug static configs into. And what a static config says is, Eclipse Layout Kernel, if you encounter a diagram element of that class, that might be the surrounding node of the whole mind map. It might be just one part of the mind map, whatever it is. If you see an element of that class, then set the option with this ID to this value. Okay, so very simple. Once you see an element of that class, set that option to that value. But how do you get those layout options? Well, you experiment. And we have a few tools for you to experiment with. And one of those tools, or the primary tool rather, is the layout view. So once I open the layout view and select the diagram, I see all the options that I can set on the whole diagram. Once I select a node, I can see pretty much the options that are valid for that node. That's pretty much the properties view just for another use case, right? So the first thing I'd like to do with you is change the layout algorithm, which is fortunate because then you see how many layout algorithms we have. Okay, so you see a few layout algorithms there. Elk layout is the one that's selected right now. Elk force, we have a force-based algorithm in the Eclipse layout kernel. We have box layout, a fixed layouter that doesn't do much, but is necessary for some special use cases. And of course, we have a randomizer, which I used to draw the modern art with, you saw at the beginning of the talk. For this kind of layout, I think I'm going to go with a tree-based layout algorithm. It's called Elk Mr. Tree. With the subtitle, We Pity the Fool Who Doesn't Use Mr. Tree. And just out of the box, it gives us this result. That's already quite nice, but I do want to increase the spacing because there's some node edge overlaps over there. So let me just increase that slightly by doubling it, and we get this kind of result. So immediately, just by experimenting around with the available options, I have a layout that I think is okay. And yeah, the only thing that's left for us is to just define static configurations so that every time we lay out a mind map diagram, we're using these kinds of options. Okay, so let's do that. And we're going to use the infamous extension editor. And let me just add the core layout config extension point here and add a new static config. So the static config requires me to input a class name, an option ID, and a value. Where do I get the class name and where do I get the option ID? I have no idea about those, but the layout view has one. So I'll just select the option I want to configure and the diagram element, in this case the whole diagram, and press the info button, and it gives me all the information I need. So the domain model class that I want to set layout on is nethypotenuse GMF editor mind map map. So let me just copy that over. And the option I want to configure is org eclipse elk algorithm. So here's the domain model class. I could also use a class of the view model. You can see in the dialog that there's also the diagram part plus the map edit part. I can input that as well. The layout kernel will recognize those as well. And I wanted to configure the algorithm option, and that's this one over there, and set it to the algorithm, the layout algorithm ID, which is that one. And I'll save my static config. And well, let's configure the object spacing as well. So here's the object spacing. I find out the map again, the domain model class, and I remember the spacing. I could just copy the ID, but I'll just go through the dialog. So we need another static config. Add the domain model class, select the option, which is the spacing option, and set that to 40. I'll save the whole thing, close my other instance, making sure that I don't save the configuration for the current diagram, because if I save the configuration for the current diagram, the layout configuration would be saved as well. That's what I don't want. I want it to be properly configured through the extension point.
Where is it saved?
It's actually for the GMF diagram layout manager. It's actually saved in the GMF in the GMF model, but that varies. You can, that depends on the diagram layout manager you have. Not all diagram layout managers will actually support saving layout options. Okay, so let's start that one again. Wait about half an hour on my computer. This is not the only kind of configuration we can have. You can imagine that you might want to have different kinds of configurations depending on what kind of state your diagram is in, or what kind of diagram elements you encounter. So that's something we support as well, but it's a bit more complicated, so we won't go into more detail there. So that's my original diagram without anything configured. If I hit layout now, we have the configuration that we wanted, just by adding stuff to the extension point. Okay, that pretty much concludes the little tutorial of how to use Elk. It's installing, connecting, configuring. The configuring part is usually the one that's most interesting. The connecting part is sometimes the one that's most labor intensive and most unnerving. Okay, so we've seen a very simple kind of diagram. So let's see what other things we can do with automatic layout by looking at a few case studies, because everyone loves case studies. So one of the things we've done with automatic layout is this kind of thing. Has anyone heard of the Ptolemy tool developed at UC Berkeley? Okay, so a few of you. It allows people to program using a graphical language. And the diagrams tend to be very hierarchical. So there's a node and there's a whole diagram inside that node. And in Ptolemy, you have to open each layer of hierarchy in a different window. So you can imagine how your desktop looks after browsing through a very complex model. And we wanted to try our methods on that. So we built an automatic layout-based viewer for those kinds of models. And we can just go in and expand that and see the whole thing in the same window with everything computed through automatic layout. Right? We can also go in and see different types of models. So in this case, we have a different layout algorithm. Let me enlarge that. A different layout algorithm that is more suited towards state machines. So in each level of hierarchy, we can have different layout algorithms. And if I expand that state, that's a different layout algorithm yet again. If I want to just concentrate on that state, what automatic layouts also gives us is the ability to just increase the zoom level over there and just make everything else get a bit more in the background so we can concentrate on that without forgetting the surrounding context. So this is stuff that's not really possible without automatic layout. Another use case, one which might be more interesting to you as you are developers, are two projects that we've published as an EPL-based open source project on GitHub that's called OpenKeeler. And the first of those is an automatic class diagram generation. So I have here a project with a few Java classes, and I've already prepared a selection of classes that I can just conjure up. And what it does is it gives me an immediate representation of the classes I wanted to look at. This is a completely synthesized view based on the information I selected and using automatic layout to place everything and route everything. That's not very, very interesting, so let's visualize a bit more. Now we have a few methods there that might give them a bit more detail. And again, it's a very effective way of quickly getting an overview of the classes in your project. So that's one of the things we can do. And another quite interesting thing, in my opinion, I just conjured up all my Java programming abilities and put together this program. And I have a breakpoint over there. So let's run the program until the breakpoint hits. We're switching into the debugging perspective any minute. And if I want to inspect the data structures, in this case it's a list and a map, then going through the variables view is not very effective. I could try to do that, and now I already selected it, so the whole fun's been kind of going away. But let me just select the map instead. And instead of having to go through the tree view, we get an immediate visual representation of what this data structure looks like, with the Dark Knight connected directly or mapped to Christopher Nolan, which makes the best Batman movies, but that's a topic for another time probably. Okay, so that's a few use cases that we've come up with. So what's next? What's next? We're a pretty new project at Eclipse, that is. And one of the, well, we have quite a few things that we want to do in the future. And the first thing would be to get rid of the K-graph, our central data structure. That sounds scary, and it is. But we want to replace it by a better data structure. One of the problems was that the K-graph was actually intended to be a very, very, very generic data structure for representing graphs. And the whole layout positioning information aspect was just an afterthought, which is not really suitable for a library that's completely targeted at automatic layout. So why not make automatic layout information first-class citizen? And that's one of the things we want to do with the out graph. We would just want to make the data structure easier to program with and easier to understand. We also want to support hyper edges out of the box, so that one edge does not just have one single source point and one single target point, but an arbitrary number of source points and an arbitrary number of target points. Now the thing is, none of our layout algorithms supports that yet, but one of the reasons for that is because our data structure doesn't support that yet. So there's lots to come, I hope. The second thing is easier configuration. I showed you a very, very easy way to configure automatic layout by just plugging static configs into the extension point. We have very, very complicated ways of configuring automatic layout, believe me. That's one thing my colleague at the university came up with, and he wants to change that because he isn't really happy with that anymore, and I don't understand half of the methods. So we want to really simplify that part of the layout kernel and give you an easier way of configuring automatic layout. Another thing, and most of you might be familiar with this point, is more documentation. We started out as a university project. I think we're doing quite well in terms of documentation, if you keep that in the back of your head. but there has to be more of it. We need more tutorials, more getting started guides. Actually, I just completed the getting started guide for you guys for connecting GMF editors today. So check out our homepage and you hopefully get started fine. And the most important thing, we need a proper logo. Okay, that's pretty much the end. That was the Eclipse Layout Kernel. You'll find us at our brand new, shiny, sparkling Eclipse website. I also showed you parts of the Open Keeler project, which is available at GitHub. And just drop me a mail or just grab hold of me during the rest of the conference. And if you want to find out more about what other people in the industry are doing with automatic layout, because actually our stuff is used in industry applications, also feel free to drop an email to Tristan. Thank you very much.